Two fair coins were tossed, and it's known that at least one of them was a head. Find the probability that both of them are heads. Alright, so when you're starting something like this, you might have an intuition here, but you want to be careful about your intuition, especially on some of these probability problems. Intuitions are notoriously wrong when coming to probabilities. You want to rely a lot on these formulas, in my opinion. So looking at this problem, it would be relatively easy to write up a sample space. So that's where I'm going to start. The sample space, if we're flipping two coins, we could get both being heads, we could get a heads and a tails, we could get a tails and a heads, or we could get tails and a tails. There's only 4 possible outcomes here. Let's see. Let's say that, let's give these events some names. At least one of them is a head. We'll call E. Both of them were heads. We'll call that F. So we're trying to find, well, I guess, let's see, E. Let me write up what the what these events are. The probability, or rather, the event that at least one of them was a head. Let's see, we have both of them being heads. The first one is a head, or the second one is a head. Those are the 3 outcomes where we have at least one of them being a head. F, the event that both of them are heads. Well, that's obviously only the one outcome. And so if we're trying to find what is the probability of F given E, then the easiest way to do this one, since we have the number of outcomes in each of these events, is just use n of E intersect F divided by n of, actually I guess we would usually write that F intersect E. It's the same thing, but whatever for consistency. N of F intersect E divided by n of E. It's always divided by the, we're always dividing by the condition. This was the given event. Notice that it's the thing that ends up on the bottom here. So the number of outcomes, well, let's actually go ahead and say what is E intersect F. Well, if you start off with all of E and cross off everything that's not in F, pretty quickly you can see we end up with just the one event. So n of F intersect E is 1. N of E is 3. There's a 1/3 probability that at least one of them was a head, or that both of them were heads, if we know at least one was a head. And that kind of makes sense. If you think about your sample space here, if you know at least one of them are heads, you're essentially just saying, let's get rid of that one. We know, the only thing we know about this is that they weren't both tails. There's 3 different ways that that could happen. One of those 3 ways was both of them being heads, so that's where we get this 1 out of 3 is our probability.